Hey y'all, I've got a question here from the Homework Help subreddit by user cherrysnail, and the user asks help finding x for these triangles here. So we've been given some triangles, and we're supposed to notice that they are similar, and then write up some relationships about the lengths of their sides, specifically the ratios of the lengths of their corresponding sides, and those will be expressions in x. Then we would use those in our algebraic knowledge to solve for x. In the comment section, Cherry Snail says that his or their teacher didn't teach them this. And that is really, really, really common in geometry. Actually, maybe even starting after geometry. They don't spoon feed you things. They try to lead you to it, and then hopefully you would have enough knowledge to just connect it and get there. This one, you need to reach back and actually get some of your algebra. So that may be tough for you, but you can do it. Just give yourself permission to use any of the tools that you have and reach, for the puzzle, really strive to finish that. So let's just walk through it. And I don't know if this is the user's markings on the diagram here, but they have, so this angle is vertical, so it's congruent to that angle. And then this must be given. I'm not sure, I believe this is given. So they have that these two angles are congruent. Maybe they drew that in. Let's see. So this one looks to be right to me, but I wouldn't assume that unless I was told otherwise. Oh, I see. They drew in these vertical angles, but this was given. So angle M is congruent to angle F. Okay, so that's actually enough for us to get similar triangles through angle, angle, angle. So we have two similar triangles here. And we can say that triangle, let's call it triangle LMD is similar to triangle, this would be EFD, okay? So that means this side corresponds to this side, and this side corresponds to this side. Now we can make a relationship. So we can say 10x plus 2 over 65, so the ratio of these sides is equal to the ratio of these sides. And so we get 8 over 10. Now we can multiply by 65 on both sides, and then we get 10x plus 2 is equal to, so what is this? This is going to be equal to 8 times 65 over 10, and we'll get 4, and then we can cancel a 5 here, so this is going to be 13. Let me check that. 1, yes. And then I'll bring this up here, so that's going to be 10x plus 2 equal to 52. Okay. Now we're going to subtract 2 from both sides and then divide by 10, and we'll get x equal to 5. So that is our answer. That's what we wanted to solve for. And you could plug this back into the expressions for the lengths of our sides and figure that out. The hard part here was just recognizing they're similar and then having, giving yourself the permission to actually write this expression. If 10x plus 2 is the length of that side, then of course you can go ahead and do this. I'm going to pause the video and then bring up the next one. All right, similar thing going on here. Angle U is congruent to angle U, since equality is reflexive, right? And let's see. It doesn't say, it doesn't give us an angle measure here or here or here or here. And I don't believe that it was given that this line is parallel to this line, but that's what they want us to infer. There may be some more context surrounding this that we don't see. Actually, let me look. So in the problem as it's given, there's no more context surrounding it. I wouldn't normally assume that these are similar, but the user said themselves that that's what they're discussing in class right now, so we're going to assume that these triangles are similar. And since they're similar, we can make some ratios of the sides. So 6x will correspond to 24, and 110 will correspond to 40. So I can say 6x over 110 is equal to 24 over 40. I'll multiply both sides by 110. I get 6x equals 24 times 110 over 40. We can cancel a 10 and a 10, and then 4 and 6, and this becomes x equals 11. And that's the solution. I took some liberties there with that assumption that these triangles are similar, but I think it's pretty clear from the exercise that that's actually what they want you to do. There was some stuff scribbled out around, so maybe that context would have added to that. I'm not really sure. I think the take-home is just like give yourself permission to use all of your tools. You took algebra last year, so you're really strong with these rational functions and just like solving for x in general. You're really good at that, and maybe you've forgotten a little bit about quadratics, but I think you could probably do this once you just see those two ratios. So great question. Keep up the hard work, and don't get dispirited by these things that are just like head scratchers. Take them 15 minutes. Take a break, come back at it later, and if you have any more questions, post them.